Assalamu alaikum students. Today we shall continue from the last paper which we were doing, Feb March 2019 and second variant. So question number 3 says two substances, solution D and solution E and solid E were analyzed. Solution D was dilute sulfuric acid. Tests were done on the substances. So tests on solution D. Complete the expected observations. Solution D was divided into 4 equal portions in 4 test tubes. Part A. The pH of the first portion solution D was tested. So you have to tell what is the pH of the first portion solution D, and solution D, as we know, is a dilute sulfuric acid. So sulfuric acid is basically a strong acid. It is considered to be a strong acid. And the pH values or range for the strong acid is basically within, you can say, near the pH value of 0. So we can say pH is between 1 to 3. pH range of this much is indicating a strong acid. So we will write 1 to 3 over here. Now second part A, second part B. It says a strip of magnesium ribbon was added to the second portion of solution D. The gas produced was tested. Now we have to give the observations. So reactions between the magnesium ribbon and that of the solution D, again, that's an acid. So magnesium is a metal which reacts with a sulfuric acid. So for this purpose, we should know the background of this reaction. You know, whenever a metal reacts with an acid, it produces salt plus hydrogen gas. So we will write the symbolic equation over here. Now that will give us magnesium sulfate plus hydrogen gas. Now it says the observations. So observation will be that of the appearance in the solution, and we know that hydrogen gas is a gas, so it will be visible in the form of the fizz, bubbles, or effervescence. So we write fizzing or fizz or bubbles. This is basically the observation of the gas, and then the gas produced was tested. So you have to tell the observation of the test as well. So for hydrogen gas, you should know the test for the hydrogen gas, and for that purpose, I will take you to the notes of the hydrogen gas. How do we testify hydrogen? So from here you can see hydrogen gas is basically uh, tested by placing a burning split at the mouth of the test tube. A burning split is used here, or you can also say the word lighted splint. Either say the word burning splint or the lighted splint. Now, how does splint looks like? This is a stick, a wooden stick. This is the splint, and you can see here closely that that is lighted, and when it comes near to the mouth of the test tube containing the hydrogen gas, then it will extinguish the flame. You can see the burning split is extinguished with a pop sound. So a kind of a considerable pop sound is heard whenever we have a sprint in near the mouth of the test tube containing the hydrogen gas. So that's the observation. The burning splint is extinguished with a pop sound or just pops, Or you can also say a squeaky pop sound. A lead splint gives a squeaky pop sound along extinguishing. So you can use any words over here. It extinguish and gives a squeaky pop sound or just pop sound. So we will write here that lighted splint or flame, lighted splint or flame produces pop sound or squeaky pop. You can also say the full word. It is a squeaky pop. Now, next question C, dilute nitric acid and aqueous silver nitrate were added to the third portion of solution D. Give the observations. So observations of nitric acid, aqueous silver nitrate, and sulfuric acid. So I will write HNO3, which is nitric acid. Aqueous silver nitrate is AgNO3 in the aqueous form, and solution D is sulfuric acid. So basically, you must refer to the test of ions and gases to know the answer. So I will take you to the notes containing the test for ions and gases from here. Now, it says if we check for the test for the sulfate ions, then it requires dilute nitric acid. It requires dilute nitric acid. So when dilute nitric acid is added, then it must be reacted with the barium nitrate solution. But in our case, we are using silver nitrate, which means if we just consider only the barium nitrate, then it must produce barium sulfate. I can write the equation here. HNO3 plus barium nitrate. It is the gas is basically providing the acidic condition. Instead, I will write barium nitrate BaNO3 sulfate ion. That sulfate ion can become for simplicity. Now, when this reaction will occur, then barium will be reacting with the sulfate and nitrate will be freed. It will be removed from the barium compound. So that will become barium sulfate. Now this so you can see here barium nitrate reacting with the sulfate. So the thing is that this test was used to identify the sulfate ion, but in our case we are reacting the silver nitrate over here, not the sulfate ion. We are reacting silver nitrate with the sulfate ion from the sulfuric acid. Sulfuric acid is providing the sulfate ion that is reacting with the AgNO3. So here it shall become AgNO3 plus Ag2SO4 because silver has a -2 charge, so that's why it should be the formula silver sulfate. Will be formed in this way when we have the reaction between the silver nitrate and the sulfuric acid that should produce Ag2SO4. So we will write no precipitates. So no precipitates, or we also say no change. So both are approved answers. Then next is D. Dilute nitric acid and aqueous barium nitrate were added to the fourth portion of solution D. Give observations. Now that's the thing which we have just seen in the notes. When there is a reaction between the barium nitrate with the sulfuric acid, then in this case barium sulfate is produced, and that is a white precipitate. That white precipitate is a clear observation of the formation of barium sulfate. So yeah, we will write white precipitate formation. So white precipitate formations is there in this case. Now next question, some of the tests and observation are shown. Test on solid E. The appearance solid E was studied. It was a white solid. Then test 1 says solid E was heated gently and then more strongly. White solid residue was obtained. Distilled water was added to the residue and the pH mixture was tested that gave a pH value of 10, which is alkaline, strongly alkaline solution, or near the, we will not just say strongly, it is weakly alkaline, sorry. It is weakly alkaline. So this is produced. Now, test 2 says dilute hydrochloric acid was added and it produced a rapid effervescence. Now, effervescence indicates formation of the gas. The gas produced was tested, which turned lime water milky. So there's only one gas that gives this test, which we know as carbon dioxide gas, which turns lime water milky. Now distilled water was added to the solution and the mixture was shaken. So it was shaken. An excess of aqueous sodium hydroxide was added to the mixture. White precipitate form which was insoluble in excess. Identify the gas produced in test 2. So we have already identified that is carbon dioxide gas. Now what conclusion could you draw about solid E? We have to tell the identity of the solid E over here. So how do we know which compound was that? If we come back to uh, test number 1, it is a solid. So we should know the formula should be of a solid, and then distilled water was added to residue. pH was tested, which is pH value is high, which means the metal which is bonded over here must be the of group number 1 or group number 2. When it was react with the hydrochloric acid, it produced gases, which means that's supposed to be a carbonate, metal carbonate. A metal carbonate could be reacted with the HCl to produce a gas, CO2, that turned lime water milky. So metal carbonate is there, but which metal carbonate is that we have to find out from this statement that excess of sodium hydroxide was added to the mixture and white precipitate was formed which was insoluble in excess. Now for this purpose, for this time we have to go back to the test of ions and gases. We already familiar that the gas, that like the anion part of the compound is the carbonate ion because it produces a lime, it produces a carbon dioxide, we produce lime water milky. Okay, now uh, it produces a carbon dioxide, and the formation of uh, converting lime water milky is basically, yeah, So now the remaining part is that of the metal part. How do we know which metal was there? For this purpose, we have to go to this table. So if we check for calcium, it says reaction with yeah, over here. This table indicates identifying the cations by reacting with the sodium hydroxide solution. So in this row, calcium ion, the white precipitate was formed. This is insoluble in excess NaOH. So even if you drop excess amount of the alkaline solution, which in this case is NaOH, then the precipitate will remain inside of the test tube. That is an indication of the calcium ion in the compound. You can see from here as well as from here. This table also indicates that sodium hydroxide is added to the solution containing calcium ions and precipitate is insoluble in excess. So this is an indication that the compound should be calcium carbonate. It is calcium carbonate compound. Now next question. 4. The rate of reaction between magnesium and dilute hydrochloric acid can be followed by measuring the volume of hydrogen gas produced. Plan an experiment to investigate the effect of decreasing the temperature on the rate of this reaction by measuring the volume of the hydrogen gas produced. You are provided with the magnesium ribbon, dilute hydrochloric acid, and common laboratory apparatus. You are advised to draw a label diagram of the apparatus you would use in the space provided. Okay, so here we are supposed to give an elaborated answer of 6 marks, and we are supposed to indicate how the reaction was carried out, because we are supposed to find the rate of the reaction, which means we must have some sort of timer over here, which means we can use stopwatch. And the available chemicals include magnesium ribbon, HCl. So it is a reaction between the metal and the acid. We know that metal and acid produce salt and hydrogen gas. So salt is magnesium chloride, MgCl2, and the gas is hydrogen gas. So uh, measuring the volume of the gas will indicate the rate of the reaction, and that is being associated with the decreasing the temperature. All right. Uh, the first thing is that you should know which type of reaction it is. It is of the reaction between metal and acid. So magnesium is given in the form of the ribbon. Magnesium ribbon is there, and it is a solid, which means it must have some sort of mass. So if you want to compare, if you want to study the effect of the temperature, then you are supposed to keep the amount of the mass of the magnesium solid being constant. So amount of magnesium is measured and it should be remain constant and kept constant. Then HCl is used. It is a solution. HCl is a solution because water is added in the HCl gas to make a solution. So we will say the concentration of the HCl is measured and kept constant. Kept constant means we are supposed to repeat the experiment multiple times because we have to study the effect of temperature. So temperature to use to heat, basically we are supposed to check the temperature. So burner will be used to heat the HCl solution. So if we have to heat the HCl over here, and the volume HCl concentration is measured and kept constant, you can say volume of HCl is known. It should be known. And weight amount of the magnesium is used because these are what you are keeping constant. Weight amount of magnesium is used. Now, since the hydrogen gas is to be collected and their volume should be used for this purpose, you are going to use a gas syringe. Gas syringe is used for collecting the hydrogen gas, or the other method is using the measuring cylinder over water, which is inverted. Measuring cylinder over water, I'm going to show you the diagram for this experiment. Measuring cylinder over water, and since the radio direction uh, is to be studied here, so which means you are going to use a stopwatch to time that experiment. But the volume of the hydrogen gas uh, collected should be hydrogen collected in same or fixed time. You're supposed to collect the hydrogen gas or measure the volume of hydrogen gas at fixed time. No, this whole part was done at one particular temperature because you're going to study the effect of the temperature, which means when you will repeat the experiment, then you have to keep another temperature there. You have to maintain another temperature, repeat experiment with different temperature of HCl solution. The temperature of the HCl solution will be different in other experiment, and then you will compare the results. You will compare the results of different experiments to see how decreasing the temperature of HCl showed the rate of the reaction. Now I'm gonna show you the diagram for this case. If you remember from the chapter of rate of reaction, then this was a case where calcium chloride, in which calcium carbonate in the form of the marble chips were used. Calcium carbonate is basically the marble chips in the solid form that was poured into those were dropped into the HCl solution, and that produced hydrogen gas, which you can see here in the form of the bubbles coming out of the flask, and they are entering into the gas range. And this gas range has a plunger on other side, which moves according to the gas being entered into the gas range. So these are the diagram which you can draw for this case, and you can also put a burner over here. That burner will be heating, and but the thing is that you are supposed to repeat the experiment, which means you should have a separate setup of the burner and the flask, and a thermometer can also be drawn to measure the temperature of that acid solution in different experiment. Do not do not put the burner for only one single experiment and changing the temperature. That is a different case, and that is wrong. You cannot vary the temperature for a single experiment. You are supposed to do separate experiments with separate temperatures or different temperatures, not for a single not for a single experiment with varying with varying magnitude of the or intensity of the flame. That is wrong. So either use this experiment, or the other way is that you can have these diagrams, and you can also uh, draw another diagram from here. This is the second way of collecting the gas, which is measuring cylinder, which is turned upside down or inverted over the water. And then this is a delivery tube. This is a delivery tube which you can use to transfer the gas from the conical flask to the water trough or bathtub, and which goes up into the measuring cylinder. So these are the diagram which you can draw for this particular experiment. You either use the gas syringe diagram or use a collection of the gas over the water. So in these ways you can get your right answers. So that was all about this question of finding the rate of the reaction. And definitely, yeah, one more diagram which I want to show you. This is a stopwatch here. This stopwatch is to be shown along with the other operators because you are supposed to find the rate of the reaction, and that has to be timed. So do draw a stopwatch along with this setup. So that was all about this question, and we have completed this paper of Feb March 2019 second variant. We'll continue with these lessons with other variants of ATP and other exam series. Till then, take care and Allah Hafiz, students.
किसी वीडियो शूट किया किसी